Hello everyone and welcome to our virtual discovery club this week. This week we are going to be learning a little bit about density and we're going to be doing an experiment that you can do at home too. So this one, all you need is 2 glass jars. Any size will do. These ones are a little big. They don't have to be that big. You need 1 to be hot water and 1 to be cold water. And then we need our 2 food colorings. So I did blue and red because blue is typically for cold and red is typically for hot. You can do any 2 colors, but if you do have blue and red, I think that's the best way to go. Also, you need a tray, something to catch the water just in case it spills, and a little card of some sort. So that card, you can see it in the back there. It's that white card. So I used cardstock, which is just thick paper. But even better is if you have something that has kind of a plasticky covering to it. So if you had a playing card or maybe a piece of laminated paper, that's going to be even better than what I used. But one thing, you want to make sure it covers the entire top of your lid. And that's all you need. So let's get started with this hot-cold density experiment. All right, so step 1 for this experiment is just to put that blue food coloring in your cold water and then put your red food coloring in your hot water. I had to stir it a little bit with the cold water, but in the hot water it dispersed a little bit better. If you leave it for a while, it should disperse on its own, but it's up to you if you want to stir it or if you want to kind of let it go on its own. All right, your next step is to put that card that you have over the top of the red, so the hot water container. So you want to completely cover that top because you're going to be flipping it over and placing it on top of the cold water container. So at first you're going to have that card in the middle of them. You want to make sure the tops of each lid are lined up almost perfectly if you can get it that way. And then you're going to very slowly, very gently remove that card from in between your hot water and your cold water. And you'll see once that card is removed that the waters don't mix. The reason for this is that when 2 liquids of different densities are combined, the liquid with lower density floats on top of the denser liquid. So in this case, we saw that hot water has a lower density than cold water. That's why it stayed on the top and didn't mix. When water is heated, the water molecules begin to bounce off each other, causing them to move further apart and thus create more space between the molecules. Eventually, a volume of hot water contains fewer molecules and weighs less than a volume of cold water. As a result, hot water is less dense than cold water. When you place the jar containing hot water on top of the jar containing cold water, the cold water does not have to rise because it's denser than the hot water and thus remains at the bottom. But what do you think will happen if we try it the other way, where the cold water is on top and the hot water is on the bottom? Will they mix? Yes. When you place the jar with cold water on top of the jar with hot water, the hot water rises to the top because it is less dense. So it mixes with the cold water along the way and creates a purple color.